Good morning, everyone. My name is Tamara Jonkman. I'm one of the 3 PhDs working in the Women Food Entrepreneurs Project. Unfortunately, I couldn't be there today, so that's why I'm doing this presentation by video. Um, Maybe some of you remember me. I did a soil survey in the urban gardens of Kisumu in 2016, and that's also what I wanted to present to you today. One of the groups that we work with within the project is food producers. And both in Kisumu and Ouagadougou, the other city that we work in, have extensive urban gardens. And most of these urban gardens are used to grow vegetables. This happens in many cities, but there's not a lot known about it because it mostly happens on a small scale, and because of this, there are quite a few assumptions regarding urban gardening. And the principal one is that because of the intensity of the practice and the small scale, that it is something that depletes the soil of nutrients. Now, the second assumption is that because of the proximity of industry and traffic, that there is a lot of pollution in these urban gardens, and especially when it comes to heavy metals. Now, for this survey, I visited in the summer of 2016 in Kisumu, and I visited Ouagadougou in the fall of 2016. And per city, we visited 3 locations. And for Kisumu, this was the Nyalenda Urban Gardens, the Obunga Urban Gardens, and the site of the Bala Group just outside of Nyalenda. And in each of the site, I dug several soil pits. I described the soil, but I also took samples to analyze back in Amsterdam. And today I'm presenting you some of the results. And most of these results concern the first 30 to 50 centimeters of the soil, because this is where the plants are most active. This is where their roots are, where they absorb water, and where they absorb nutrients. Now, I created a form for the results of the soil survey, which you'll see displayed on the screen. And I wanted to walk you through some of the results by using this form. Now, the first soil characteristic displayed on the form is the pH, which is a measure for the acidity of the soil, with 1 being very acidic and 12 being very alkaline. Now, plants prefer a pH ranging from pH 5 to pH 8, and on average, the soil in the Kisumu urban gardens has a pH of 6.4, which is a perfectly fine average. And it's one of the pH ranges at which the plants have the least amount of difficulty getting nutrients from the soil. So that's pretty optimal. Now, the second characteristic displayed on the form is the EC, which stands for electronic conductivity. And this is a measure of the amount of soluble salts in the soil. If the amount of soluble salts is very high, it becomes difficult for plants to absorb water. And this is not really a concern in Kisumu, and the values show this. But it can be a problem in Ouagadougou, which is quite a bit drier than Kisumu, as it lies just underneath the Sahara Desert. And they also only have 1 rainy season a year, lasting from May to September, after which it's dry for the rest of the year. Now, the third element is of concern to Kisumu, but it's a concern to all soils, and all soils certainly used for agricultural purposes, and that's percentage OM, which stands for organic matter. Now, for most soils in general, the organic matter percentage ranges between 1 and 6. And on average, in Kisumu, we find an organic matter percentage of 9%, which is very high, and this is good for the soil, because organic matter can provide nutrients to plants, and it improves soil structure and texture. Here you see the 3 principal pools from which the plants take nutrients, one of them being the organic matter, the second one being the mineral pool, and the third being the mineral reserve, which is basically the nutrients contained in rocks, stones, and gravel. On the screen, you see a list of all the nutrients that plants need to grow. And the first two columns are the macroelements, and the secondary elements are the nutrients that plants need the most of. And some of them are probably familiar to you, like nitrogen and phosphorus and potassium. But plants need more than that. They also need calcium and magnesium, but also microelements. And these are things like iron and copper and zinc. But they need these nutrients to a far lesser degree. Now the table you see here is from one of the forms. It shows the exchangeable nutrients. Most of the exchangeable nutrients fall under the secondary elements, but they are still quite important for plant growth. The exchangeable nutrients are available from the second pool of nutrients, the mineral pool. And overall in Kisumu, the urban gardens are quite rich in these nutrients, which you can see here very well, as most of them fall under the high label. But it's also visible due to the CEC, which is the cation exchange capacity. The higher the CEC, the more nutrients there are in the soil. Now, most of the nutrients displayed in the exchangeable nutrients table are from the macroelements and the secondary elements list, but the plants also need microelements. They don't need a lot of them, but it's better for them if they are available. And here you see encased in the red boxes, 3 of those elements, copper, zinc, and nickel. And you can see that nickel is too low in the soil for us to measure with our equipment, but there is copper and zinc in the soil. Now there are also some other elements in this table, also metals, but these are the so-called heavy metals, and they are here again encased in red boxes, and they are arsenic, lead, chromium, and cadmium. Now arsenic and cadmium are so low, they are below the limits of detection for our equipment, so that's very good because these are not desirable elements to have in your soil. We do see lead and chromium in the Kisumu soil, but especially the lead is so low that these are considered background levels. It is a naturally occurring element, so these are not levels of any concern. Chromium is a little higher, but still falls within the classification of low by international standards. So to summarize the results of the soil survey, what we found was that the Kisumu soils are quite rich in nutrients. So there's no evidence of nutrient depletion. This is likely due to a combination of nutrient-rich parent material and good agricultural management by the urban gardeners. And also there is no evidence of heavy metal pollution in the urban gardens of Kisumu. So pretty good. And finally, I wanted to tell you just a little bit about what we're currently doing, which is we're looking at using the nutrients in the mineral reserve, which is the nutrients that are in rocks, to make them more easily available to plants. And through this, hopefully increase crop quality and also potentially yields. Now, for this experiment, we gathered rocks from the surrounding of Kisumu, and we ground these to a very fine powdery dust. And this rock dust was then added to Kisumu soil samples. And right now we're looking to see what the soil does in response to this addition. We're hopeful that the microorganisms in the soil are capable of releasing the nutrients in this powder to the soil and hopefully also plants. Unfortunately, the results of this experiment are not yet in, but I'm hoping by the next time we meet, I'll have some results to show to you. With that, I have to conclude my presentation. Thank you so much for your attention. I hope you all have a great day at the Stakeholder Dialogue, and hopefully next time we meet, it will be face-to-face again.